In this short video, we'll discuss the L'Hopital's rules, one of the rules which you can use in order to find the limits of a certain function using the derivative. You can consider as this one of the applications of the derivative. So the theory goes, given that the limit of f prime of x divided by g prime of x when x goes to c exists, right? So this limits exist, and when you plug c into f of x and g of x, you get the form 0 over 0, or plus or minus infinity over plus or minus infinity. Then the limit of the function f of x divided by g of x when x goes to c equals to the limit of f prime of x divided by g prime of x when x goes to c, with the condition that the g prime of x is not 0. So when you are running into the form of 0 over 0 or positive negative infinity over positive negative infinity, they are one of the indeterminate forms. So if you run into one of the indeterminate forms, you can use a L'Hopital's rule to find the derivative of a certain function. All right, let's look at an example. Finding the limit of 1 minus cosine of x divided by x squared when x goes to 0. If you plug 0 into x's, you get 0 over 0. Then yes, we have one of the indeterminate forms, right? Then you can use the L'Hopital's rule, which is taking the derivative of the top functions divided by the derivative of the bottom function, which we get the limit of x goes to 0, of sine of x divided by 2x. So sine of x is the derivative of 1 minus cosine of x, and 2x is the derivative of x squared. At this point, we're trying to plug the value of 0 into x's again, and we get 0 over to 0 again. So again, this is one of the indeterminate form. That means we can keep using the L'Hopital's rule the second time by, differentiate sine of x and 2x. And then you get the limit of x go to 0 of cosine of x over 2. And at this point, you should plug 0 into the x's to see if you can find the limit using the direct substitution. If you plug 0 into cosine of x, you get 1 over 2. So by the conclusion, the limit of x go to 0 of 1 minus cosine of x over x squared is 1 over 2. And you found this limit using the L'Hopital's rule, not one time, but twice. All right, now it's your turn to try. Look at this limit. If you plug 0 into the x's, you get 0 over 0. Can you find this limit using the L'Hopital's rule? Have fun.